GameSide.com. GameSide.com.
Woohoo! We're getting near the end of the videos I have to record, so I'm happy about that. I am Professor Chris Ferguson, and welcome to the video on JavaScript JSON. JSON stands for JavaScript Object Notation, or JSON. JSON, or JavaScript Object Notation, is a lightweight data interchange format. It is easy for humans to read and write. It is easy for machines to parse and generate. JSON is a text format that is completely language independent, but uses conventions that are familiar to programmers of C, C++, Java, JavaScript, PHP, Python, and many others. These properties make JSON an ideal data interchange format. That is according to JSON.org. JSON makes it easy to exchange objects. That's me. When I think about JSON, I think about objects going back and forth, not just data. The browser or client computer. JSON is really about exchanging objects. On the client side, we build and use a JavaScript object. At the last second, we use the function JSON.stringify to convert to a string and send the string to the server. It's in a format which makes it easy for the server to recreate the same object. When the server replies, it sends the JSON format string. The client runs the JSON.parse to recreate the same object sent from the server. Technically, it's strings going back and forth, but practically, it's objects being exchanged. I build and use an object on the client side. I want to send it to the server. I convert it to a string and send the string over. Same thing in the reverse direction. They're working with an object on their side. They convert it to a string, and when they want to send it back, they send it back as a JSON format string. The server computer number 2. These are two computers. This is client-server architecture. The browser is the client. On the server computer, it receives a JSON format string, plain text, sent from the browser. It immediately runs its function to make it an object. The server processes that object, or creates a new object, to send back to the browser. Just prior to the send, it runs the function to convert the object to a JSON format string, plain text. That string is sent back to the browser, which uses JSON.parse to recreate the object. Technically, it's strings or text going back and forth between the computers, but practically it's objects being exchanged. Technically, it's strings or text going back and forth, but practically it's objects being exchanged. On the server side, they're manipulating the data in whatever object format that language supports, and at the last second, they convert it to a JSON format string. Follow this arrow right here. That JSON format string is sent back to the JSON string on the client. The client then uses the parse to convert it back to a JSON object. It's a good time now to point out that JSON is language independent. Over on the server side, if you're running PHP, you'd create a PHP object. If you're running Python, you'd create a Python object. If you're running Java, you'd create a Java object. Let's look at some code that does this. We'll set up an object equals command is weather, city is Dallas. A JSON object is almost exactly the same as a standard JavaScript object, except for the double quotes around command and city are required. If I was setting up a plain old JavaScript object, I wouldn't need the double quotes around command. I wouldn't need the double quotes around city. Those were added for JSON and JSON only. There are many ways to create and build an object. This is not the only way to build an object in JavaScript. You can build the object any way you want. I'm just doing this to show you the JSON format. If you want to change the object, it's trivial, right? You go to object.command and you could change it to time. You could go to object.city and change it to New York. When you have data that's part of an object, it's very easy to change. And when we're working in the JavaScript side, we want to use it as an object. This is going to be our server request. We're going to ask for the weather in the city of Dallas. Now to send this object to the server, we have to convert it to a string. JSON str equals JSON.stringify and pass it this object that we created above. You cannot send the object as is over the internet. JSON.stringify will copy every property and its value and build a plain text string that you can send over the internet. While this is a copy of the data in the object, it looks a lot like the object. This is just a plain text string. This is a string variable, and these are just plain characters in the string right here that we are about to send to the server. Boom. Move it across to the server. Send the JSON string to the server. So this text that was on the browser computer or the client gets sent over to the server, and there is the same text on the server. The plain text string is sent over the internet, and the server then converts it to its own object format. Look what's happening here. It takes the JSON string that it receives and makes an object out of it. Now, I'm doing an example here in PHP. I'm assuming the server program here is PHP, but it doesn't have to be a PHP. It can be any program that can run on the server, can receive the object and convert it to its own object format. I've now created a PHP object out of that JSON string that was sent to me. The JavaScript object on the client side was transferred using a string and then was reborn as a server-side object. Again, this is PHP here, but I want to stress JSON is language independent. You could send that string to any language on the server and it'll build an object in its own format. We're still running the code on the server side. Later in that code, we're going to send or get a reply from the server. The server program uses the object to process the request and builds a new object with the reply. More data has been added to the object. As you can see, there's more data that's been added to the object. That is our reply. The server then converts the new object to a plain text string, which can be sent over the internet. Again, you can't send an object as is over the internet, but you can send strings or text over the internet. So what we're going to do on the server side is take our new object with the updated data. Object temperature is 87 and object conditions is cloudy. We're going to take that and convert it to a plain text string. Once it's converted to a plain text string, the server will send it back to the browser or to the client with the updates included. We're back on the client side now. We're back in JavaScript. JavaScript is going to receive the string reply from the server and they're going to do a JSON string equals server.response text. Bang! The JavaScript program on the client, our browser side, reads the plain text string the server sent in reply. As of now, this is just a plain old string. It's not quite an object yet, but it contains the data we requested. The next step is critical. Right now, we're at a point where the reply string has been sent from the server. Object equals JSON.parse JSON string. Boom! The plain text string is converted to a full JavaScript object. The object, seen as OBJ in this example, can now be used like any other object. It contains the new data. It contains that the temperature is 87. It contains the current conditions, cond, is cloudy. We've got our reply on what the weather is like in Dallas. Did you see how we transferred an object on the server back to the client and then JavaScript made it an object? We received the string first, then converted the string to an object, and now we have this lovely object on the browser side where the command is weather, the city is Dallas, the temperature is 87, and the conditions are cloudy. Document.getElementById of weather.innerHTML equals. I have a span or a div on my browser that says this is where I want to plug in the weather report. And I'm going to build the weather report out of the data in this object. I'm going to set the city to Dallas. I'm going to set the temperature to 87. I'm going to set the conditions to cloudy. At this point, OBJ is an object. It can be used to change the element on the screen with the ID equals weather. The weather for city Dallas, temperature is 87, conditions is cloudy. Now, if I had more room, I could do a fancier screen update. Heck, if I had more room, I would have spelled out the word conditions here instead of cont. I would have made the variable condition instead of cont. But I don't have more room. I have to kind of squeeze it in there. And you know how dynamic screen updates and objects work at this point. You can do whatever you want with that data in there. You could put all sorts of fancy formatting and display a nice weather. You could do an if statement. If it's cloudy, show a picture of clouds. Make it as fancy as you want. I don't have room to do the real fancy stuff here, but you can do whatever you want with that data. It is a simple pattern. Build an object in JavaScript. When you want to send it to the server, convert the object to a string with json.stringify and send the string to the server. When the reply returns, it is a plain text string. Convert it to an object with json.parse and use that object to update the screen or update anything you want. Technically, we're sending strings back and forth between the client and the server, but in reality, we're sending objects back and forth. I have an object in JavaScript I want to send to the server. I convert it to a string and I send it across. On the server side, it receives a string and converts it to an object for its language. When it wants to send a reply, it takes its object, converts it to string, sends it back to the client. AJAX, jQuery, and JSON. Transfer JSON, or really anything, between the client and server. The JSON does not jump back and forth between the client/browser and the server all by itself. You need AJAX, which stands for Asynchronous JavaScript and XML. Or you could use jQuery to do that. AJAX was designed for XML exchange, but JSON has pushed aside XML. This whole thing was invented to send XML back and forth, and when JSON came along, everybody said, ooh, that's better, let's send JSON back and forth instead of XML. If you're already using jQuery, it can be used for even easier AJAX or simple file access on the server. But it's not just JSON. I want to make this clear. You're not limited to sending JSON back and forth. If you want to send HTML back and forth, you can do that. If you want to send plain text back and forth, you can do that. You can send images back and forth. You can send anything you want back and forth using AJAX or jQuery. On the browser or client side, the JavaScript program on the browser/client wants to get JSON from the server so it can dynamically update a web page. Typically, it sends a request to the server to run a CGI program that will return JSON or HTML or text or whatever you want for display. But this is not a server CGI programming class. Luckily, AJAX and jQuery can request a simple file from the server and it will send back the JSON or HTML or text from the file. We're studying JSON in this lesson and we'll use JSON as an example. Let's go get a JSON file and get it back from the server. But I want to make it very clear you can go get any file off the server and send it back to the client. On the server side of the exchange, server is computer number 2. It would be great if you learned a server CGI programming language like PHP or Python or ASP. And that is when you can create truly dynamic web pages that access a database on the server side and update your web page in real time. But this is a JavaScript course, so we'll focus on AJAX and jQuery to request a simple file from the server containing JSON or HTML or text or whatever we're trying to grab. The web page then dynamically updates with the data from the file, no CGI programming required, just a simple file upload from the server. So what we're going to concentrate on this slide is the client's going to make a request to read a file off the server and the server's going to send it back. No CGI required. Server equals new XML HTTP request. This is AJAX. Create a server object to request a file we can use to dynamically update the current web page. XML HTTP request is built in and can request JSON files or HTML files or programs being run, etc. from the server. The original idea was it was going to transfer XML back and forth, but today it's more often used for transferring JSON back and forth. Server.open, get me the file special.json. Server is an object. Run the open method and tell the server we want to get request of a file named special.json. At this point, the server is storing that info, not sending the actual request. Server is recording what you want, but not sending the request yet. The file must be in the same folder as the HTML file making the request. We can request any type of file we want. We could even run a CGI program that will return JSON or HTML or text, whatever we want. This is saying I just want a file. I could put an HTTP here and run a program over on the server with no HTTP in front and no directory information. It's saying just load this file from my current folder on the server, the folder where my HTML and my JavaScript file are at. Server.onReadyStateChange equals getJSON. This is event-driven programming. Assign the name of the function to run when the server replies. This is what we call a callback function. At this point, no request of the server has been made. These last 3 lines are set up for the request. They don't actually send the request to the server. So what I'm doing here is I'm setting up the request for the file special.json. I have not made the request yet. Servers typically send 2 or 3 updates back to the client, and each time the function getJSON will run, but it doesn't run yet. What you're saying on this line of code is when the server contacts you, this is the function I want to run. Server.send, pass it the parameter null. Bang! Send the request for the file to the server, but do not wait for the reply. No one knows how long it will take the server to reply. It could be 0.002 seconds, could be 2 full seconds, it could be 2 minutes before you get a reply from the server. The web page continues to operate as normal. The callback will notify the page when the reply is returned. This is what asynchronous means, right? The A in AJAX stands for asynchronous. It means when the request gets sent to the server, the client doesn't wait for the reply. It continues on. You can see what's happening here. The client sends the request to the server. That's what the send method does. It takes this information, sends it off to the server. It asks for the file special.json, so the request has now been made to the server. We will not run getJSON until a reply is sent. Function getJSON. Whoop, there it is. After a delay of who knows how long, the callback function is run. That's what asynchronous means. It did not directly jump from this line to that line to run that code. The request was sent, and at some point in the future, a reply came from the server, and that's when this function gets invoked. This is asynchronous. It runs when the server reply event occurs. This allows the page to operate as normal until the reply is received. When getJSON runs, it doesn't mean that the data has arrived. It could just be a notice or some sort of error reply. So the request has been made to the server, and the server notifies the client, I have something to tell you. And the client executes getJSON. If server.readyState equals 4 and server.status equals 200. The server will often reply with several updates before the actual data is sent back. This if statement will only be true when the actual requested data has been received. Execute the code to read the data sent from the file special.json on the server. So when this if statement is true, it will go inside this code and read the data. The server might have sent 2 or 3 notices back, and each time getJSON run, but this time when it ran, the server notified the client the data has arrived. We've got confirmation that the real data is now available. var reply equals server.response text. The server is an object in this example. Objects have methods like open and send, right there and right there. Objects have properties like onReadyStateChange and response text. Once you verify this is the actual data, the response text property will contain the data from the file special.json sent from the server. This is a file sitting on the server. I sent it back to the client, and now the client has it in its variable reply. All the text from the file is now in this reply string. It's from a JSON file. We'll say JSON object equals JSON.parse of the reply. We will convert the string to a JSON object. JSON object now is a fully functioning object on the browser with properties we can use to easily update the web page to display a daily special on the home page of the website. The next day, when there is a new special, just replace the special.json file on the server and the page updates automatically. So today, this is what the file contained. So I'll update my web page to say product ID 1234 is an iPhone and it costs this amount of money. And that's what I'll show on the web page today. The next day, maybe a Samsung phone is on special. So I will change just this file, special.json, and I'll put a Samsung phone in this JSON. And when it gets sent back to the browser and displayed, it'll show today's special, the Samsung phone. The goal here is not to update the main web page HTML. I don't want to have to go edit my main web page every day. What I'd rather do is every day set up a new special file, send that across, and display the new special when it's ready. The previous example uses straight JavaScript and AJAX to send the request. jQuery has automated a lot of this work, and a lot of people love jQuery because it does AJAX also in addition to it. We're still using AJAX here. It's just jQuery will be handling the AJAX for us. So we'll say script source equals jQuery.min.js. To use jQuery, the first thing you do is include it on your web page. This example uses a file on our server, but you could also load it from the Google server. If you're planning to use jQuery for other purposes, you might as well use it for AJAX too, or dynamic load of an HTML file. We're going to change this example to a little bit. We're going to go grab HTML off the server instead of JSON. Is that clear? jQuery has AJAX built into it. If you're already using jQuery, you might as well use it for AJAX also. Div ID equals special. Click for daily special, end of div. A simple div tag in the HTML file where we want to display the daily special. We will also use the ID equals special to attach jQuery to this element and do the dynamic update for us. jQuery will do both. It'll do the AJAX loading of the file from the server, and it will do the dynamic update of the page. So this is a div tag as it would appear on the browser web page. This is the tag, and it'll say click for daily special. And the intention is if I click on this area of the screen, it will load and display a special. Switch over to the JavaScript file. The code above this line belongs in your HTML file. The code below belongs in your JavaScript or jQuery file. It can go in the script tags at the top of the web page, but that's not as good as having a separate JavaScript file. The code below the comment is jQuery JavaScript. Technically, yes, this is JavaScript, but it's JavaScript that's using jQuery. $document.ready and pass it an anonymous function. This is the start of the jQuery command. This is the end of that very same command. This is the jQuery code. It calls the jQuery function. $sign is an alias for jQuery, and it passes it the DOM. The ready method is event-driven and executes after the page is fully loaded. The parameter is what we call an anonymous or callback function. This anonymous function is executed when the ready method runs. I read this as jQuery document.ready. jQuery $special.click and pass it this anonymous function. This is how jQuery sets up event-driven code. It is the body of the asynchronous function above. It tells jQuery to run the click method only when the user clicks on the element with the ID equals special. When or if the click runs, then the anonymous function parameter for click is executed. So I'm over here on my browser and I click on the daily special. That's when this code will run. Not before, not after. If I never click here, this never runs. If I click here 3 times, this will run 3 times. That's event-driven code. $$ special .load special.html. This code only executes when the div with ID equals special is clicked. It will replace the inner HTML for the div with the HTML read from the file special.html. There is also a jQuery AJAX method you can call if you want to load JSON or other types of file from the server, but load does it both. Load will do the AJAX exchange for me, and it will update the web page. That's why I like this call. It does both the AJAX load and the web page update from me. If this line of code executes, it will go pull the file off the server, send it back to the client, and it will replace the inner HTML for the div with the special. Now I just did a very simple little iPhone for sale in an H1 tag, but this could be a full-on block of HTML that does a very, very nice display with links to click on to buy it. It could be a lot more HTML than what I've shown here. Remember, I'm always limited by space. I only have so much room on these slides. I could have done, 5, 6, 10 different HTML tags in here and did a really nice job of displaying a special. And it's just like the last example. If I want to update the special on my main web page, I don't have to go edit the main web page every day. I can leave the main web page alone, and every day I substitute in a new HTML file, and every time someone loads their web page, they will see what's currently in that special file. To be honest, there are so many different ways to dynamically update the screen with JSON, AJAX, and jQuery. We cannot even cover a fraction of them. What is important is that you learn the patterns. For example, have you spotted that $$ special is just the jQuery version of calling document.getElementById special? jQuery isn't new. It isn't special. It's easier because it automates a lot of the tasks that we had to do before by ourselves in JavaScript. For example, this load command is actually doing the AJAX exchange and updating the inner HTML in one command. Once you get good at jQuery, it takes fewer lines of code to update your web page than it takes with standard JavaScript. Last slide in this video. JavaScript cookies. Me like cookies, according to the Cookie Monster in Sesame Street. Be careful. We're not talking about client server here anymore, right? What we're talking about here is a JavaScript program that wants to store a cookie. It's going to store it not on the server, but on the user's hard drive, on their own computer. You're browsing a website on your computer. These cookies are stored on your computer. When you want to read the cookie back, it comes off your hard drive and back into your JavaScript program. Web pages have no memory. All those beautiful JavaScript variables you create and store values into are gone. All gone when you exit the browser or reload the web page, or even if you surf to other web pages. JavaScript programs don't have memory. Their data goes away when the program goes away. Cookies are memory. They can stick around for days, weeks, months, even after the browser exits and the computer powers off. If you want to store some information, you use a cookie in JavaScript. The browser stores the cookie. The JavaScript commands ask the browser to write and read the cookies from the user's disk drive. It may look like in these examples that JavaScript is storing the cookie, but all JavaScript is doing is requesting the browser to store the cookie. That's why there's always an option on a browser to disable cookies. And if the browser says I won't write a cookie, then your JavaScript is not going to write a cookie. So here's a short example using cookies. This is JavaScript code. Document.cookie equals, quote, first name equals Bob, end of quote. What is that? Creating a cookie is a simple matter of assigning it to the cookie property in the DOM. Cookies are stored in name equals value pairs. The name in this case is first name, and the value is Bob. This will ask the browser to write the cookie to the disk drive. They are stored under the web URL, so when you return to the same web page, the same cookie is provided to your web page. So when this line of code executes, we're asking the browser for this URL, save me this cookie, first name equals Bob. When you want to retrieve the cookie, var cookie string equals document.cookie. Go back to the DOM and get the cookie. Using a cookie is a simple matter of assigning it from the cookie property in the DOM. This retrieves the name equal value pair as one entity. The cookie is read from the disk drive. Only the cookie value for the same web page URL is retrieved. If you've visited 5 different web pages that have stored cookies, you only get the cookie for the specific page you're on. So if I go to page number 1, I get page number 1's cookie. If I go to page number 2, I get page number 2's cookies. Look what's happening with this command. I'm requesting the cookie. The cookie is read from the disk drive file and stored in this cookie string variable in my JavaScript. Now all I'm going to do is sort of break up the data that's stored in the cookie. I'm going to say var cook array equals cookie string.split on the equals sign. The split method will chop up a string into pieces using the parameter equal sign as a separator and assign the result to an array. Since there is only one equal sign, the resulting array contains just 2 elements, the name and the value. The split method is used a lot to process cookies. Google JavaScript split to learn more about the split method. But really all we're doing here is splitting this string, this bigger string, into 2 pieces using that equal sign. And the first one goes into slot 0 of the cook array, and the second piece goes into slot 1 of the cook array. Name equals cook array position 0 of the array. Value equals cook array position 1 of the array. This code is to emphasize that an individual cookie is stored as a name equal value pair. Clearly the name is first name and the value is Bob. I'm just taking the data out of the array and storing it in a name variable. Taking the data out of the array and storing it in the value variable. These last 3 lines are more about processing the cookie than actually storing and retrieving it. Document.cookie equals last name equals Jones, semicolon, expires Monday, 6th of April, 26. When you create a new cookie, it appends to the existing cookies. It does not replace the current cookie unless you use the same name. So now we have 2 cookies stored on this web URL. Also notice the expires equal. That was added. This is required to make sure the cookie is stored until the date listed, April 6, 2026. Without this, the cookie would be deleted on shutdown. This is telling the cookie, I want you to stick around until this date. Without it, the cookie could disappear. More importantly, follow the arrow. We already set first name equal to Bob. When I add another cookie, it appends on and creates last name equals Jones, so now I'm storing 2 cookies. The first one I set up here, and the second one I set here. Normally the equal overwrites what's in the variable. In this case of cookies, it adds to what's in the variable. Var myCookie equals document.cookie, retrieve my updated cookies. Now that we extract the cookie from the DOM, we get both name equal value pairs. To break them apart, we could use myCookie.split on the semicolon. Each new cookie appends to the list, so the more cookies that have a unique name, the more cookies will be returned by this command. I now have 2 cookies stored on my hard drive, so when I say retrieve the cookies, I get a much larger string. I get first name equals Bob, semicolon, last name equals Jones. I get both cookies. Now at this point, I could use split to divide this up and grab the different pieces out of it. I'll leave that as an exercise for you, the student. That's the heart of using cookies in JavaScript. I store them and I retrieve them. Once I retrieve them, it's up to me what I do with them. 2 points before I leave. First, the expires equals is important. Without it, the next time the browser exits, the first name cookie will be deleted and the last name cookie will be kept until April 6, 2026. Second, the code to store cookies is a separate function than the code that retrieves the cookies, not bunched up like on this slide. I don't normally store a cookie and then immediately retrieve it. I have, say, one function that stores the cookies for me, and then I have a separate function that retrieves the cookies. Wow, that wraps up this slide and this set of videos. There are a lot of work putting together these videos. I hope you enjoyed them. Good day and good luck.